Okay, so here's our two formulas. Cosine of 2 theta is cosine squared minus sine squared, and that comes from the a squared minus b squared. And the sine 2 theta is 2 sine theta cosine theta. Well, you already know a couple angles. What's cosine of 45 degrees, or pi over 4?
Root 2 over 2.
And what's sine of 45?
Also root 2 over 2.
And how about cosine of 90?
Well, by our formula, this is, so it's cosine squared is this squared.
Yep. So what is root 2 over 2 squared?
1/2.
Okay.
Minus a half, so it's 0.
Okay, is cosine 90 0?
Correct.
What is sine of 90? Do you know it without calculating?
It's 1.
Okay. What does our formula say?
So 2 times, so it's root 2, and then times root 2 over 2. That's 1.
Neat, huh?
Yep.
Now, how about let's do 30 degrees. What's cosine of 30 degrees?
So that is 1/2, or no, root 3 over 2.
Root 3 over 2. How about sine of 30?
Sine is 1/2.
Very good. Do you know what cosine of 60 is?
1/2.
Okay, let's see, does it work from our formula?
So it's going to be 3/4 minus 1/4, 2/4, 1/2.
Yeah. How about sine of 60? What is sine of 60 to begin with?
So that's root 3 over 2.
Okay.
So that's 1 times root 3 over 2. So it works.
Okay. And now here's a neat one. See, you don't know what this angle is in a 3, 4, 5 triangle. Okay. It's not 30 or 60 or
Nothing
50.
nice.
Okay. But if I call this theta, I can tell you what cosine of 2 theta is, because it's cosine squared. What's cosine of this angle?
Looks like it's 3.
It's definitely not 3.
Well, oh yeah, we're not in a unit circle.
Right.
So is that opposite to adjacent?
It's adjacent to hypotenuse. It's the x value. And then scaled by the hypotenuse. So cosine of theta.
So 3/5.
3/5. What about sine theta?
It's 4/5.
4/5. Okay. So if I double the angle, the cosine becomes 9/25 minus 16/25. So that's, if I did it right, it's minus 7/25. And what about sine?
So it's 8/5 times 3/5. So that would be 24/5.
24. 24/25.
Oh yeah.
Sorry. So this triangle looks like this. If I have my axes, it goes over minus 7, up 24. So I have a 7, 24, 25 triangle over here, but this is my doubled angle here.
Wow.
Okay. So twice the angle in a 3, 4, 5 triangle. Twice this angle produces this outside angle in a 7, 24, 25 triangle. So 3, 4, 5 and a 7, 24 related. And by the way, there's lots of other formulas you can find just from this simple exponential expression. So it's a neat connection. Sanderson was showing you the connection to Pythagorean triples. There's also an amazing connection to trigonometry. It's pretty cool, huh? All right, have fun.